Good morning, students. Today we can start exercise 8.2. So let us start exercise 8.2, case number 1. ABCD is a quadrilateral. So first I draw a quadrilateral here. I given the name A, B, C, D here. Okay. In which P, Q, R, S are midpoints of the side AB, BC, CD and DA respectively. That means P should be the midpoint of AB, I marked here. Q should be the midpoint of BC, marked here. And R should be the midpoint of DC, marked here. And S should be the midpoint of AD, marked here. Okay. After that, I joined all these points together. I got another quadrilateral PQRS. Okay. And it is given that integration AC is a diagonal. So I joined the diagonal AC by using dotted lines. This is diagonal AC. Okay. So the figure over. Next, we have to prove that first of all, SR is parallel to AC. So this SR is parallel to AC. We have to prove that, and SR is equal to half of AC. This line is equal to half of the total length AC. This one we have to prove. Okay. So I am taking the triangle ABC, which is the triangle ABC. ABC. This is the triangle ABC. Okay. So in triangle ABC, P is the midpoint of AB. So this is the line AB. P is the midpoint. And Q is the midpoint of line BC. That we know. Correct? In triangle ABC, we know that P is midpoint of AB and here Q is midpoint of BC. Correct? I written the same statement. So we can write here, therefore PQ is parallel to AC. So if you have a triangle here, this is another theorem. Okay, remember this point. If you have a triangle here and you have two midpoints, midpoint of one side and the midpoint of another side. Okay, so if these two midpoints are joining like this, then the third side, this side AC, this side should be parallel to this midpoint joining line. This is one theorem. Okay, this you should by heart. If you have a triangle here and you are marking midpoints of two sides and joining these midpoints, then this midpoint joining line should be parallel to the third side, and of course this line midpoint joining. So first I am writing, therefore we can write here P is the midpoint of AB and Q is the midpoint of BC. So we can write, therefore this line PQ is parallel to AC. Like we said now, by using that theorem, we can say that these two lines are parallel, and the line PQ, this midpoint joining line PQ, we can write it as half of this third side. Okay, so I am writing half of its third side, that is half AC. This theorem is called midpoint theorem. What is it? Midpoint theorem. What is the midpoint theorem stating here? So if you have a triangle ABC, P is the midpoint of AB and Q is the midpoint of BC. You are joining these two midpoints, you will get a line PQ. This line PQ should be parallel to the third side of the triangle AC. This is the third side, right? These two sides we already took. So this line, midpoint joining line, should be parallel to the third side AC, and of course this line PQ should be the half of AC. This is called midpoint theorem. It is very important. Okay. So by using midpoint theorem, because we know that these two are midpoints of triangle ABC sides AB and BC. So the third side AC should be parallel to PQ and AC should be, we can write it as PQ is equal to in terms of AC. So PQ is equal to half of AC by using which theorem? Midpoint theorem. Okay. So first part over. And here we have to prove, actually not over, we have to prove that SR is parallel to AC. Correct. Now we proved PQ is parallel to AC. So I am taking the triangle ADC. I am taking the next triangle. In triangle ADC, we can write here, which is the R is the midpoint of DC. So R is midpoint of DC. Same statements I am writing here. And S is the midpoint of AD. S is the midpoint of AD. This is D. So DC. And S is the midpoint of AD. So by using the midpoint theorem, same theorem, we can write here this midpoint joining line should be parallel to the third side, correct? So we can write SR is parallel to AC, and this SR should be half of the third side AC, correct? Half of AC. So I written this same statement here. I am putting this equation as 1, this as 2. So by using these two, here we got half of AC, here also we got half of AC, correct? So from 1 and 2, we can write here this PQ is equal to SR because both are half of AC, and PQ is parallel to AC. SR also parallel to AC. So by combining these two equations, we can write here PQ is parallel to SR because PQ is parallel to AC is parallel to SR. So PQ is parallel to SR. We can write it from here, and PQ is equal to SR is equal to PQ is equal to SR is equal to, what is the answer? Half AC. That means we can write here PQ is equal to SR. Okay. So this first part over. Sorry, second part over. Next, last one. PQRS is a parallelogram. So directly we can write now in quadrilateral PQRS. If we are taking the quadrilateral PQRS, it's one pair of opposite sides PQ and SR. These two sides are equal and parallel. We proved here PQ and SR are parallel, PQ and SR are equal. So we already proved one pair of opposite sides are equal and parallel. Therefore, we can write PQRS is a parallelogram. Okay, so the proof is over.